This is Boogerman, and it took me 30 days to render him to the screen in my first month as a game developer.
I come to you from the Matrix. This is my new mic. It sounds a lot better than my camera mic. For my camera, I'm using my phone, which is a Pixel 6 Pro. This is my first month completed in full-time game dev. Here's an update. The first week, I took a Casey Neistat course on filmography, and I stopped doing Casey's course. There was quite a bit to learn. Good stuff. It took too much time away from development during a phase where everything is up in the air and nothing is concrete. It's not as if I've started my game yet. And so I put the Casey course on the back burner. Definitely recorded quite a bit about cooking, how I prepare food, which isn't interesting to anybody. So yeah. So the other 3 weeks of the month have been fleshing out technical options for an engine. We're all probably familiar with heavy hitters like Unreal, Unity, Godot, and then there's some fringe engines like CryEngine, Lumberyard, and Game Maker Studio. There's engines that are barely engines, more so like frameworks. One in particular is called Bevy, and it caught my interest for a few weeks. Bevy is written in Rust. Rust is cool. More about Rust in a minute. Back in 2006, I was learning to code games from scratch with C++. Having gone to Full Sail for game development, I left with a feeling of confidence in game dev. 13 years later, when I jumped back in, I was surprised to find my confidence within these new engines to be completely shattered. Everything is UI driven. The architecture of the game loop is very opinionated. Implementation of scripts is event based. The industry as a whole has seemed to shifted to this ECS lifecycle over object-oriented programming, and the YouTube dev vlogs are nearly void of code-first content or tutorials. A lot has changed, and I needed a month to catch up. These are the things I've learned. Dev vlogs are filled almost entirely with level-based, designed static scenes. Right? They're kind of simple. Tile-based 2D games often hack the engine to bypass the bloated game object paradigm, whatever, the built-in engine thing to get better rendering performance. Procedural worlds are possible, though, given enough time and learning the opinions of that engine. Dev posts on online forums indicate platforms and libraries over an engine is suggested if you want to build a game without an editor. And ECS, this entity component system, where all your memory, all your game components are stored in arrays for better cache hits during your game loop. It's worth further exploration, although it's a huge departure from what I've learned and used in my career. They say don't build game engines, and building a game engine is a great way to build a game engine instead of a game. And while I can certainly agree that game engine development that's for general consumption is best left to the veterans of the game industry, but purpose-built engines have their place. After graduating, I remember having clarity and confidence in architecture of any game idea I had. I think getting to that level of mastery within a commercial game engine is possible after enough time and brainpower investment. But given the dynamic sandbox nature of this simulation game, I think a purpose-built engine still seems viable. And so I think that settles it for me. There's an engine I still have my eye on, but for now, I think I just need to pick a language. In my career over the last 13 years, I've used C#, JavaScript, and TypeScript primarily. I've mixed in a little bit of Golang and some nasty Pascal Delphi. It seems like there's always that legacy thing lingering around any organization. High-level web languages are a joy to work with, and you can get tons of stuff done with very little code. There are some games on Steam built with web tech, using Electron as a packager where it spits out a binary in the end, and it runs JavaScript front end, Node back end in a box, right? And to the end user, it's just a binary. It feels like a native app. Like Visual Studio Code, Slack, these use Electron. But the problem with those is the V8 runtime, which is like the Chrome engine running within it is running scripted code in a just-in-time format, and consoles do not allow scripted languages for security reasons. And everything on a console has to be precompiled, and I don't know if my game will be on consoles, but it'd be a shame to be blocked out just because of the language. C# would be a natural choice given my experience with it. C# compiles down to an intermediate language that's interpreted by a runtime, and it uses a garbage collector. And so I don't care for garbage collectors because they can randomly introduce hiccups and sudden loss of frames per second when the garbage collector decides it's going to clean up memory. But plenty of games are made with C#, so that's still on the table. C++ is still around and kicking. It's not my favorite language for productivity, but it certainly is performant, and it does give you complete control over the memory. Golang is a newer language. It's in the same category, I guess, as C++. It's way simpler. I never much cared for the syntax of Go. Then there's one of the newest kids on the block, Rust. It has a borrow checker built into its compiler that watches how you use memory and sort of proactively prevents you from creating dangling references to memory that's been cleaned up or memory that's shared across threads. It protects it. Rust is being considered in place of C for future Linux kernel development. The interwebs indicate it's kind of the next evolution for C and C++ devs. It's just so much better at preventing application explosions than developers are. I will say learning to appease the borrow checker has made it the most difficult language I've ever begun learning. They say you get over the hump in a few months. Hopefully that's true. So rendering to the screen. I originally thought that I'd be using Vulkan. It's a newer cross-platform, high-performance API used to submit draw calls to your graphics card, right? And then I came across WebGPU. When you visit websites with rich 3D content, most likely they've been using WebGL. WebGPU is the next thing that's going to replace WebGL. And I was surprised to learn that it's not just for the browser. It's for native systems as well. Rust's implementation of WebGPU is called WGPU-RS, and I've played with that for a few weeks now. It's cool because it's kind of this truly cross-platform across all, Mac, Windows, Linux, and the browser, which is cool. You can actually compile native apps like Rust into browser-capable code using WebAssembly. Early performance numbers indicate it's faster than DirectX, which is used for Windows, way faster than OpenGL, which is used everywhere, and it's only slightly slower than just pure Vulkan. These are some of the projects I've been referencing, and these are some of the projects I've built using Rust. Hello World was a triangle, and then I moved on to Pong, building out a little menu, and this is where I started to play with ECS. Then I drew some textures. This is Boogerman, where it's just they're drawn, but they're obviously not, retaining their aspect ratio. And then this is I Am GUI, which is a C++ library UI thing that I think it's used for like console output and debug menus within a game. This wouldn't be your actual menu, but it's a very popular thing. Somebody rewrapped it for Rust. And then, so this is Stardew Valley. I wish I could say I did this. And something I noticed about this, you can zoom out, and that's cool. And as you change the window, aspect ratio is maintained, but the camera continues to zoom out as you resize it. And I've got 6 monitors. I can stretch this across almost 6 of them, and I definitely see things that I don't think are intentional. And so what I've done with my latest Boogerman is when I resize, he maintains his aspect ratio. but he also scales to sort of, if he's spinning and his legs and head when horizontal are using 50% of the window width, that kind of tracks regardless of size. And so I think that's what I want. And I got a true orthographic camera with zoom. So yeah, that's where I'm at. Obviously, this could have been done in like a few hours within an actual game engine, but I wanted to know how to write shaders. I wanted to have full control over, these details, like, not being able to zoom out forever. So yeah,